Hello, everyone. This is Vietnam Smart Agriculture. My name is Carlos Moran-Esparza, and this is our team. We're made up of 8 multidisciplinary engineers with a passion to help others. Our goal is to create efficiency in agriculture by promoting sustainable agricultural technology that allows for the protection of crops against harmful environmental conditions. We want to ensure that our project has these criteria of being low cost, able to be used efficiently, be able to understand easily, as well as being maintainable. And how we implement this goal is by talking to our farmers in Vietnam. Over the summer, we had this chance in August by talking to 3 different farmers from the same cooperative farm. And what we found was that at all the same scale in these farms, we found that there was an issue of overexposure to sun, as well as an issue with acid rain. Acid rain is caused by the burning of coal. And what we found was that China is actually one of the world's biggest coal burners. And due to its geographical location near Vietnam, it causes acid rain to emerge and causes the agricultural industry to suffer due to that. When we interviewed these farmers, we talked about things that we want to know about them, such as how do they get their water, how do they pay for their electricity, and things that cooperate with them, such as do they work with the unison and cooperatives, or do they have to pay for their seed, or is there a discount for them when they buy in bulk? And what we also wanted to find out was baseline understandings of what causes these farmers large issues, such as is there any environmental issues that are causing this? And when we all talked to all 3 farmers shown here on this geographical location in Da Nang, we found that all of them agreed that there was an issue with the rain, and the rain was no longer a benefit, but a hindrance to them. What we found was that the rain actually causes issues when the plants, once it rains. Pre-existing solutions to this issue was actually using palm fronds and fish netting to prevent the rain from staying on the plant for too long. And if it does stay on the plant too long, it causes the plant to wilt or turn yellow due to the acidity of the rain. Another issue was actually the rain seeping into the soil and staying there and changing the pH. Methods that can be used to do this, to prevent this, was actually using the sprinkler or manual irrigation system to dilute the water inside the soil to prevent pH from being too acidic. What we want to do now is create a prototype that can be able to detect, send that data to a mother box, which then can activate the irrigation system, which could possibly send neutralizers or balancers into the irrigation system to balance out the pH. What we need to do for this irrigation system sensor is to do pH, humidity, soil composition, in which it can send that data wirelessly to our mother box. The reason why we want to go wireless and use Bluetooth mesh is because we don't want to be more of a hindrance to these farmers than we already are by partly invading their privacy, because it's almost shocking when you have this cultural composition. We want to be able to do this in the most passive way, which allows us to just be there and actually work with the farmer and not just work against them. Our design now is to do a small, flat, foldable mesh box, which allows us to work in a small composition area and a small area that is the farmer's cooperative. And what we found was that we want to make sure that this shell is actually able to be folded open and closed very easily to be able to be maintained and kept up very easily. But it also needs to be waterproof, as well as acid or acidically preventable, which is the reason why we chose PEPG as our filament. Our stakeholders are our 3 first interview are done by this layer. And what we found was that our 3 interview farms are our main priority, then our small farms that are nearby and a cooperative. And then from there, additional cooperatives, suppliers and buyers. And then from there, even here in the US and domestically, we can even implement this on the small scale farms here located in the US. Our business model is to implement this by doing a flatline fee for the purchasing of our materials, hardware, and software, doing an additional subscription for additional readings and data, and then the subtraction of maintenance. And with the help of the University of Da Nang, we can maintain these items in Vietnam easily with the 8 of them, and domestically we can fix them here at ASU and even able to ship them here in the US for a fairly cheap price, which allows us to be profitable. Our impact community is allowing us to be more efficient, aiding others, and allowing the reduction of labor and more free time. Our next steps is to implement, prototype, and develop, and be able to implement this in Vietnam by January 2023. And we want to invest in smart growth agriculture to ensure that the small farmer is no longer this little guy. Feel free to contact us at these medias. Thank you so much.